You've done none.
Yes, sir.
Okay. So I'm suspecting that since Friday is the holiday, it's likely most of your lecturers may be putting midterm there. So I will open mine throughout the day. I'll try and open it as early as 6 a.m. to 11:59 p.m. throughout the day. So I'll set it up on the platform so that you go just assign to be like objective questions on everything that I've taught you guys so far. And I think it will be easy for you guys to do. We'll be meeting after this meeting. When we have our next, I'm confused about the timetable. When we have our next week is online, right?
Yes, sir.
The next 2 weeks is face to face, or next 2 weeks is face to face.
Yes, please.
Okay, so we're meeting on campus. So I'm sure the group work I gave you guys, you guys have already started working on it, or you've forgotten.
Yeah, we still remember.
Yeah, so I'll try and throughout the week I'll tabulate the class list again. Then I'll share it with the coursework so that in case maybe you've forgotten the topic you are working on, I'll just share it to the coursework so that the coursework share with you guys. So that face to face, we can have our presentation for 10 marks. So the midterm is going to be the midterm is going to be 20 marks. The one you'll be doing the Friday will be 20 marks. Then the presentation will be 30 marks, making 70. Then the final exam is going to be 70 marks, making 100%. Okay. All right. So let's begin. I promised to do some recorded videos for you guys. I couldn't do it. So don't worry. I'll try and make it up to you. Maybe throughout the week. I've been very busy and Charlie, it's really something, but I'll try and make that available. That's the video recording for last week's session we were not able to meet. So I'll try and do that and make it available. Also, I have one particular topic I wish I could treat with you guys, but it's not a big topic though. So I'll see if I can also do a video with it. Or the time we do the presentation, if I'm able to finish the presentation on time, I'll try and treat that one in class. Okay, so either I'll do the video or I'll try and do that in class. So it's just a small video. I'm sure it escaped me once I was structuring the course. So I noticed that I really have to make sure I made you get that particular topic to and add it to it so that I makes the fundamentals of hardware and computing model will be complete. Okay. Now today is module 7, right? And we are going to do computer software and programming fundamentals. That's for module 7. The book I uploaded a PowerPoint on the platform, but I filled in it. I don't know how many of you downloaded it. Do you have someone in the class who downloaded it? Hello? No. Okay, so which means none of you have gone to the LMS this morning. I uploaded it yesterday at dawn, but I was trying to do some few changes to it, adding certain slides to it. So I've disabled it. So after this section, I'll complete it and put it on the platform and I'll let the course run. The first slide that was there was 20 pages, 20 slides, but this one is 30 something. I was trying to add something more to it. Still, some of the things were compacted. I just wanted to separate it so that it becomes easy and readable when you are going through the slides. Okay, so I'll make it available as soon as I finish the class. I'll just push this final one there so that you can just have it. And also I'll make the book also available for module 7 so that you can read. How many of you have been reading the book? The books, how many of you have been reading it? I'm sure some of the modules, they already have a structured book already you download, which you can use. But this module, I don't have it. So I'm just using it to do that. After the semester, I'll put everything together as one full book and I'll make it available. And maybe consequently, the other cohort will also have it at day one. They get the whole full book from starting to end. I'm sure if you go through and you read the book, you understand it perfectly because I'll try my possible best to write it in simple language so that you can always understand. So let's go to today's model, model 7. So in the earlier models, I think we've looked at what the physical part of a computer system, where we spoke about the hardware, the memory, the storage, and the operating system. We spoke about it, the operating system. We know these components I imagine these components are very important to the computer system because without them, the computer itself is nothing. But however, we just have to know that it's not just this hardware component that makes up the computer system. There are other things that also play a very crucial role. Okay. So one of the things is what we call the software, the computer software. Without the software or the computer or the hardware itself, it's nothing. It's just a dead body lying down somewhere. So when we talk about software in simple terms, okay, in simple terms, we say software is what makes the computer useful. That's what allows us to run applications, manage data, communicate, and solve problems in different areas. So we put them on the computer or any device. If you have a mobile phone, you still need software on it before you can do certain things. Okay. So in this computing, whether you want to type something, you want to print something, you want to design something, or simulate anything you want to do, you need a software in order to do that. So this particular model will look at that. Then also I'll introduce you to programming, ideas of programming process. So we're looking at program, not in-depth as in programming, but we'll look at a little surface, we'll scratch the surface of programming and look at some of the programming languages. Okay, then we look at machine language and assembly language, high level languages, then fourth generation languages. So since you are IT guys, you'll be doing a programming itself. I don't know whether you are doing principles of programming this semester. Are you doing principles of programming?
Yes, sir.
Are you are doing principles of programming?
Yes, sir.
Okay, so the programming aspect too, it's likely it's possible what I'll be taking you through. Probably you've handled it, it has been handled there. But if it hasn't been handled there, fine. Or maybe I'll be add something that probably the lecturer didn't mention it in class. So we'll just be describing it because this is fundamental. So you need to have a surface of everything, then it becomes holistically one, but not into that details as in like programming or writing codes and stuff. Okay. So we'll look at that. Then finally, we will look at how to choose the right programming language if you're about to do software, how to devise, how to choose the language to use, and how to go about it. So basically, that is what we are going to talk about in this particular model. So in a computing system, it is very important to clearly separate the two fundamentals aspects. That is the physical component and the computer component, that's the hardware, which we all know, and the instructions that's governing its operation. So the instruction, when you talk about the instruction, you're talking about the software. Okay, so you have to make sure you know to clearly separate them, understand them individually, and you understand them individually. So the physical components, which we refer as hardware, which is already done, we already know about it. That are the physical components. While the instruction that controls them is known as software. So you have a monitor, you have a keyboard, you click on it, but behind the scene, there's something that takes instruction and controls it, and that we call software. So hardware is usually the tangible, which we already talk about, is the tangible parts which you can touch, you can see, you can hold, and it has components such as the processor, memory, we talk about storage and other stuff. So those are the hardware. But software, on the other hand, is intangible. You can't see, you can't hold it. It's intangible. Okay, it's the intangible part of it. And it consists of instructions that guide the computer system and also guide the hardware system. So when you talk about software, it's not just it also guide the hardware system component to function and interact properly. Okay. So usually at this level, you can define computer software as, it can be defined as what? A collection of programs or procedures and associated document that direct computer system to perform specific tasks. That's how you can define it. So basically that's software. Okay. And the instructions are written in a form that what? It could be interpreted and executed by the computer processing unit. So even though it's a program, you may write it in plain language, but for the computer processor to interpret and execute it, it has to be formed, it has to be converted to zeros and ones, which the computer processor will understand, a binary, in order to process and execute it. Okay. So software is essential because what it provides the functions for intelligence behind all computing. Without it, hardware component will remain inactive and it will be unable to perform its useful operations. Okay. So when you come to it in simple terms, what I've said in simple terms, we can conclude to say that the hardware provides the physical capabilities, okay, from the first point here. The hardware provides the physical capabilities of the whole system, while the software provides instructions that guides it purposely and for the right direction. So the software is the direction. It directs it while the hardware provides what? The capability. Okay. As I said earlier, software is not a physical component. It's intangible. Okay, so it's not something that you can see, but rather it exists in a set of coded instructions stored in a digital form. So these instructions are what the computer executes in order to carry out different operations, such as calculations, data processing, communication, and interact with other users. So basically, when you are doing that, you are using what? The software. So over here, we have the software where you have the intangible. Then usually softwares are stored on storage media. So the software can be on the hard drive, which we've handled already. It will be stored either on SSD. You can even store the software on your pen drives or even on a CD. Previously we used to use CD a lot. You can install the software. You can store it on on those kind of storage devices. But as soon as you decide to run it, it moves towards memory, which we've already handled that in the past. Okay. So in practical terms, softwares are stored in different types of storage devices. This may include what I've mentioned earlier. Okay. So although software is intangible, it is very significant. It has a very significant influence on how computer system functions. It determines what system can do, how efficient it performs tasks, and how users would interact with it. Okay. Now let's come to components of a software. So we're talking about software, component of a software. So software is made up of several key elements that work together to deliver its overall functionality, which becomes what? A whole computer system. So the components is what we have. We have a program, we have a procedure, and we have documentation. So these are the components of any software. So when we say program, what are we talking about? So a program is a sequence of instructions written in a programming language that directs the computer on what to do. These instructions define the behavior of the system. Okay. And programming can vary in complexity, ranging from simple scripts to what? Advanced or complex scripts, which involves millions of lines of code. So it can be just simple and that's what we call program. Okay. But program alone is not a software. It has to be a software is made up, as we said, a program, a procedures, and a documentation. So if you want to become a software developer, you have to have this in mind. Don't just write the code and tell someone that you have a software. It's not a software, it's just a program. Sometimes we don't know. To have a software, you have to make sure you have all these things in place. Okay. Then when we talk about procedures, what does it mean? So procedures refers to what? A structured step-by-step instructions that explains how specific tasks should be carried out using the software. So after you do the program, you have to do the procedures, okay, to make sure you get everything complete. They guide users or software operators in the correct way to perform operations. In practical procedures, we may be called as so in some softwares you see it as what? User manual. We see it as user manual or operational guide. So that is the procedure. So to build a software, after you build a program, you need to have that in place. That any user can just look at it and see how to use your program step by step. Okay. Then when it comes to documentation, documentation provides detailed information about the software system. This includes its design, functionality, instructions to use. It serves as a reference for use. It serves as a reference for both user and developers, helping them to understand how the software works and how it should be effectively utilized and maintained. So one thing about software is when you design a program, it's not supposed to be static. I think when we go a little advanced, we may go, it's in one of the slides. It's not supposed to be static. Software can be upgraded. Sometimes it's the system that it is running on. Uh, the system may be archaic or certain devices have to be installed and the software have to be upgraded. So the documentation will be there in case it's a program where programmers can look at it so that in case they want to upgrade it, they'll look at the documentation, then they will know what to do in order not to damage the program. So these three are the components of a software system. If you just do a program, use the program, don't mention it as a software. You write some code and it's doing something, it's a program, it's never a software. For it to become a software, it has to have all these three components. Are we following?
Yes,
Yes,
sir.
sir.
All right. So categories of a software. Okay. So generally, softwares can be classified into different categories based on what its function within a computer system. So the main categories we have here, we have the system software, we have utility software, we have application software. Okay. Some books will tell you we have only system software and application software, but we have utility software also there. So these are the three categories. And each category serves a distinct purpose, which I will be explaining later as we proceed. Okay. So just keep that in mind that we have there's application software, we have utility software, and we have system software. So let's pick them. Okay. Johnson, though, your hand is up.
Yes, sir. So please, instances where you are asked to list the categories of softwares, are we allowed to list the 3 or 2? Because some lecturers say that it's 2, and others say it's 3.
The best thing I'll let you as now you know that is 3. List all the 3.
Okay, sir. So what if it's a section A question and we have 2 and 3? Which one would be the right answer there?
If I am answering, I'll choose 3.
Okay, sir.
If I am answering, I'll choose 3. Okay. Because some books will tell some books will tell you too that application software and system software. But we have utility software, which is not an application software. Do you understand?
Yes,
So
yes,
it's good that you are answering that question. So if there's a way to debate, you can debate about it. Okay. All right.
yes,
so each of them has its own purpose. Okay. So let's keep that. So let's look at the system characteristics of software itself. We'll look at software itself. We are talking about the software itself. So software has its characteristics. Okay. So when you look at the software has several characteristics that distinguish them from hardware. Okay, hardware. So one of them is that it is intangible and exists in a digital form, which I've explained earlier. It can it can be easily copied and distributed. So you can put it on a pen drive, copy it to another place, and go and just use it. You can put it on a CD and distribute it around. But you can't do that when it comes to hardware. Hardware, when you move the part, the other part, you disable the other part, or you are going to deficient the other part. Maybe you move two memory, you move one memory to another place. The other one will function, but it's going to be slow. But software is not that way. Okay. And it does not wear out physically, but may become updated. That's what I said earlier. So for hardware, some of the parts may wear out. Maybe a mouse, you are using the mouse will fall, it will get damaged, or a keyboard, water will fall on it, or other stuff. But with software, no, the only thing is that it can become updated or dated. And that's when documentations comes into that. In case the programmer wants to update it, there is documentation the programmer can follow. Okay. And it requires regular updates and maintenance. Any software, you always have to keep on updating it. And on our phone, you notice that you have an app you are using before you realize App Store or Play Store will tell you have to update it. You don't have any choice, you have to update it. Okay. So that's how software works. And it can be modified to meet changing requirements. Okay. Because sometimes if you are installing a software on your computer, you notice that sometimes the steps may even give you customs where you can activate certain things, whether you want it to install everything. So that usually they do it express or something, express or typical, where it will give you the default, or you can go to maybe custom or advanced, then where you can disable certain things you don't want or enable certain things. So it can be modified to meet changing requirements. If when you are going to install it, you don't need certain things, you can, some softwares will give you the chance to disable some of them and just focus on the main thing. If you have an Adobe suite, those of you who know Adobe Suite have, let's take CX6, for example. It has Photoshop, it has Illustrator, it has Premiere Pro, it has After Effects, it has a lot of softwares in one. But when you are installing it, will take you to a place that will tell you that, okay, do you want to install everything or you want some portion? So if you're a graphic designer and you're not video edit, you don't edit video, you can just open it and take maybe Photoshop and Illustrator and install and save space. The person who is a video editor may rather choose After Effects, maybe Adobe Premiere Pro, or maybe something else and install it instead of installing the whole suite. Okay. And with the same way we have for Visual Basic Studio. We have Visual Studio, which if you are installing, sometimes you can install C#. Later, I know maybe some of you haven't heard about it before. We have C#, we have Visual Basic. You can activate some of them and install the whole studio, or just install the portion you need. So unlike hardware, with the raise over time due to physical wear, software may continue to function indefinitely if properly maintained. However, it may become obsolete as technology evolves. So that one is there. As technology evolves, some software will become archaic. So either if it becomes archaic, whether you look for a better software, or if it can, sometimes some software have a lifespan, it has been upgraded to the version. You can't go again. Just like iPhone OS, you can upgrade if you are using, let's say, 7 or 8 or something, I think 7 or something. You can upgrade the OS. You get to a place, they'll tell you you can't go again unless you go in for a different kind of iPhone. That's where you can keep on upgrading. Even some of the softwares, you can't even install it again on an old maybe iPhone. Okay, so that's one disadvantages about characteristics. That's one advantage of the characteristics of software. Now, software development. So we spoke about software development earlier. I just mentioned on it. So it's just we just have to have a little idea about it. So software development is creating through the process known as a software is created through a process known as software development, which involves designing, coding, testing, and maintaining program. I'm sure as you proceed, you may do a full course on software development, which will delve into each of them. Okay. So for now, you should know that it involves designing. For you to design a software, to create a software, you need to design a software, maybe the interface, how it will look like, the color, we call it the GUI, the graphical interface. We look at it, then we look at the coding, where you look at which programming language you are using. Are you using C++? Are you using Java? Are you using Python? Then after you are done, you look at your testing to debug if there is error. Then you look at what maintaining it. That's how you can maintain it. So all those things are there, which is a whole course or a whole program on its own. Okay. So this process requires one. So to become a software developer, you have to have a knowledge of what? A knowledge of what? Programming language. So you have to know, you have to be a master of a particular programming language. If it's a website you are building, you have to know HTML, know CSS, know JavaScript. If possible, know MySQL, depending on what you are building. If it's a mobile app, you can probably use Python. You have to know Python. Depending on what you want to build or the software you want to develop, you have to look for the appropriate programming language that fits it, and you have to understand it. Okay. Then understanding the system requirements. So when you are developing software, you have to understand the system requirements, then careful planning and design, then test it to ensure accuracy and what? Reliability. So these are just something that you just need to just grasp through, know, so that maybe in the future when you are doing the whole software development course, at least you come up. The importance of the software. So software is central in modern computing and plays a crucial role in everyday life. So the importance is it enables communication through email messaging applications. We always send emails, we always send WhatsApp messages. And basically that's what we do. We even do it often. We will use the software. Even though the importance are a lot, these are just few. There may be some that haven't been captured yet. That doesn't mean it's not part of the importance. It also supports education through learning management system, which we can all attest to it. Then it facilitates business operations through accounting and management software. So we have businesses that you can install certain softwares which you can use to track how businesses are going. Okay. So that's it. Now let's go to system software and application software. So we've talking about the system software. We spoke about the three types: that system, application, and utility. Now let's come to system software and application software. So system and application. I think I've changed the slide. No problem. So in our previous slide, we spoke about system software and we discussed some of the rules and the functions and how important they are. Okay. But software is generally categorized based on what? Its function and the way it interacts with both what? The hardware and the user. The two primary categories are, we have the system software and application software. Even though we know I spoke about the utility software. Okay. Now, system software forms the foundation on which every computer system stands on. Without a system software, we can't have application software, you can't have utility software. Okay. So system software is the foundation and it manages and controls what the hardware and the other components, the peripheral that you connect to the computer system. The application software, on the other hand, is designed to perform specific tasks for the user, such as what? Writing documents, browsing, and the rest. So before application software will be on the PC or your device, there should be a system software there first, which the application software will be on them. Okay. Now, system software. Now let's look at the system software. So system software is a category of software that is designed to manage and control computer hardware while providing a platform for running applications program. It acts as an intermediary between the hardware and the user. Okay. So system software operates in the background. So it always runs in the background. It continues operating. So when you on your machine, as soon as the OS loads, it keeps on operating behind the background. You may be doing other things, but that doesn't stop it from operating. It always runs behind the background. And it's essential for basic functions in any computing system. Okay. Now, system software, the foundation. So we have components of system software. I think I don't know, when we say it's 5. We have operating system, we have device drivers, we have firmware, we have we have system utilities. So system software comprise several key components. We have one, the operating system, which we already know. It manages all the hardware resources, controls the background processes, provide interface. An example, we have what Linux, some people call it Linux, Windows, Mac OS, Ubuntu, all of them are part of operating system. Then we have the device drivers. So the device drivers are programs that allow the operating system to communicate with hardware devices such as printers, keyboard, and other peripherals. Okay, so sometimes when you connect a new device to your computer system, sometimes the OS has a device drivers in it. It, it has it somewhere on the OS. If it's compatible, it can install it itself. But if it's not compatible, you have to go online, go and look for the drivers for that particular device, install it on the OS before what it can interact with it. So, example, majority of our printers and scanners. There are some printers you connect automatically, it works. But some printers you have to go to their website, download their drivers, then install them before you can use them. Then when we talk about system utilities, so these are programs that perform maintenance and support tasks for the system. They help improve performance and ensure smooth operations. So they support the OS to have a smooth operation. Then we have the firmware, which I think we spoke about it earlier. So the firmware is a software that is embedded in the hardware. So we spoke about it earlier when we started this particular model, this particular course. That the firmware are programs that are on the motherboard itself. They are programs that are on the motherboard itself. I hope you all remember.
Yes, sir.
All right. So I don't need to go back to that. So functions of a system software. So system software performs several critical functions. So we have what? It manages the hardware resources such as the CPU, memory, and the storage, which we've already done it. There is a repetition. It's good that there's a repetition so that in case you've forgotten, at least to take you back. It provides a platform for application software. I've echoed that one already. It's controlling input and output operations. So that is the system software that controls everything like that. Then we have, even though it controls, earlier on we spoke about what is in the system software that does that. I hope you remember. But we are talking about system software holistically, so we can't separate the individual components of the system software. We are just considering holistically. Then ensure system security and stability, and also handling errors and system updates. So these are some of the functions of system software. Then when it comes to characteristics of system software operates close to the hardware. Sometimes the characteristics and the functions sometimes look similar. Okay, that's the characteristics. So it operates close towards the hardware. It's underground, it's close to the hardware before the application software comes on it. So between the application software and the hardware, there is a huge gap. But the system software is very close towards the hardware. It is essential for system or operations. It runs continuously in the background, which I've already mentioned, and it is usually written in low level or system level programming language. I think we'll get to that. So the system software, usually when you talk about low level languages, it's languages that the hardware understand, and the hardware components understand binary, so zeros and ones. So system softwares are written in using low languages, which at least those hardware can understand and interact with them. Okay. So examples of system software, we have operating system, such as Windows, Linux, and Mac OS. There are more. Okay. Then we have device drivers for printers and graphic cards. Then we have system utilities such as disk management tools. So all these things are system softwares. Now let's move to application software. So application software is designed to help user perform specific tasks or solve particular problems. Okay. Unlike the system software which operates in the background, application software interacts directly with the user. So the system software operates the background, but the application software is for you, the user. It always keep on interacting with you. Okay. If you are watching the movie, it's interacting with you. It doesn't care much about what the hardware or the system software that it's just you. So application software is developed to meet user needs in areas such as education, business, communication, etc. So VLC was designed for entertainment. That's why if you want to play a movie, you want to watch a movie or play music, you go and play or use VLC. If you want to browse, you go for Chrome. I don't think you want to type, you want to send a letter, then you go and open Chrome or Firefox. No, it was not designed for it. If you want to type something, you go and open Word. Because an application software, every application software is designed for a particular task. Okay. Now we have types of application software. So application software can be categorized into these three main categories based on their purpose. So we have the general purpose applications, we have the specialized applications, then we have custom software or applications. Okay, custom software applications. So when we are talking about the general purpose, so these are softwares or tools that we use on daily basis. It's for common tasks. Just as Word, you open Word, you type, you open your notepad and you type. It's just a general purpose software. Spreadsheet or your PowerPoint, your browser, they are all general purpose software and application. Then when we come to the specialized application, okay, they are designed for specific tasks or industries needs. So example is maybe a specialized software for medical. You go to the lab, they have software, you are pregnant, you are going to do scanning. They have a software on that machine that is used to scan and see whether it's a boy or female, whether they are twins and the rest. So that's the purpose, it's a specialized software. Then we have the custom software, which that's where the programmers come in. You deal with an organization. The organization tell you what they need, their requirement. Then you are forced to build a customized software to fit them. So just like the university learning management system, or let's say the SIP you use, it's a customized software built for the university, where you can go check your grades and it wasn't there like that. So the university will tell the programmer, this is how we want it. Every semester, we run course, we run modules, we do this, we do 3 terms in a year, we do this, we do so. The person has to understand the needs of the organization and customize it to fit the needs of the organization. So those are the 3 types of application software we have. So it's either for a general purpose, which is there, specialized, then we have the custom software. Any questions so far before I proceed? Any question? Okay. So let's move on. So we have functions of application software, which we have for creating and editing documents, performing calculations, and so this one is just readable. You can just read, and I'm sure you understand it. That's the same way characteristics of application software. You can also read and understand it. There's no anything technical here. So application software is user-oriented. It depends on system software to function. It is designed for specific tasks, and it is often developed using high-level programming language. I think we'll get to the high-level programming language later in a bit. I'm sure you already know, but we'll still get there. Okay. So examples of application software, we have web processing, we have spreadsheet, we have browser, we have media players, we have a lot. So anything you open as soon as on your laptop, anything you open, you use is an application software. Anything you decide to use on your machine or you use regularly is an application software. Okay. Now, key difference between system software and application software. So, although both system software and application software are essential, they differ in several important ways. So, we have when you talk about system software manages hardware and system resources, while application software performs specific user tasks. Okay. System software operates in the background while application software interacts with the user. So I think we mentioned all these things, and those are differences. System software is required for a computer to function, while application software is optional depending on the user needs. So that one too is very clear. Then we have what system software provides the platform for application software to run on. So one is on top of the other. Before the other one will come, the other one have to exist. And that's some of the differences. And when you go through the PowerPoint, I think we have it here. I'm sure the book tool that I'll be uploading have majority of the content, which probably are not in the slides. Okay. Now, even though they have differences, what's the relationship? They also have relationship. Okay, anything that have difference will surely have it can be a positive relationship or a negative relationship, but there's still be a relationship between them. So the relationship between a system software and application software is interdependent. Okay. So application software relies on what system software. As I said earlier, that's the relationship. It relies on the system software to access hardware resources. For example, a Word application uses operating system to display text. So when there is no operating system, you can't install the Word in the first place. Okay. The system software also ensures that multiple applications can run simultaneously without conflict, which we did earlier. So that's some of their relationship. So system software will support application software in order for the system to run multiple applications at the same time without affecting how fast or how slow the system will become. Okay. So this layer structure allows what computer system to operate effectively and provide flexibility for users to install and use different applications. So that's one of them. Then let's come to the utility software itself. Now, when we talk about utility software refers to a set of programs designed to help manage, maintain, and optimize computer systems. So they are there for that. These programs perform supportive functions that enhance the overall performance and usability of the system. Okay. Utility software operates in the background or is used periodically by users and system administrators to perform what maintenance tasks. So those are what the utility software. We'll look at more examples, I think, when we move ahead of it. Or any of you have example of utility software? Do you have anybody who have an example of utility software? Again, no, we have IT teachers in the class already. Mm-hmm. Okay. So utility software. Okay, Johnson, no.
Yes, sir.
All right.
So please, the utility software and the application software was not uploaded. When I studied the slides this morning around 2 o'clock, and it's
Yes.
not part of the slides.
You joined us late, right?
No, I joined earlier in the morning, but I was now coming to work, so I couldn't speak in the car.
Oh, okay, no problem. When I started, I informed the class that I uploaded it at dawn, but later I decided to update it. So after the session, I'm going to upload the updated version of the slide.
Okay, sir.
So I've even hidden it. So when I'm done, you can just delete what you have, then you can download the new one. I noticed I left it was compacted, so I decided to just separate and add some few things to it.
Okay. Because I tried downloading the new one again and it's not even working.
Yeah. I've disabled it. I just want to finish and upload a new one. This one I'm
Okay,
using.
sure.
Okay, so
Okay,
you
sure.
can have the copy of it.
Okay.
All right.
Sure. Thank you, sir.
Thank you. Okay. So functions of a utility software. So utility software performs several important functions that contribute to the smooth operation of a computer system. So we have what? The system maintenance. Okay. So we have system maintenance. This is one of the what? Functions of utility software. So utility programs will maintain the system by identifying and correcting issues that may affect performance. So example is what? The disk cleanup tool that remove unnecessary files. So on your computer, we have sometimes the OS comes with that tool by default, which you can use to remove temporal files. Or you can sometimes, if you don't have the software, you can have command, you can go to some command prompt to do that. But sometimes some of the OS comes with that by default, which you can use to what? Then we have what the disk defragmentation tool. I think the last time I showed you that one. Okay. I hope you remember the disk defragmentation tool where you can defragment the hardware. The hard drive, whereby to optimize it. So that's one of what a utility software. But if it doesn't come with it, you can sometimes install it and use it. Okay. Then we have what for performance optimization. So if you have utility software that improves performance by managing what system resources efficiently. So we have the memory optimization tool, which help manage how memory is used, startup management tools, which controls which program runs when the system starts. So you can do that. You can, sometimes when you start your computer, there are some laptops that a lot of programs will be running. Everything has to start. So you wait and wait and wait. Now antivirus have to kick. Now another thing have to come. So we have the starter which you can even go there and disable some of the softwares that don't need to. You think you don't need to come with what the starter. Then you can disable them to in order for your system to run smoothly anytime you boot your system. Then we have the data management. So we have data management. Okay. So utility program assists in organizing and managing stored data. So this includes file compression. Then we have backup and recovery. So on the system, so the backup and the restore and the recovery, sometimes it can, if you are using Windows, it comes automatically with it. If your sometimes your Windows is corrupted or is messing up, you can go, if you've created a backup, you can go and restore. Or you can even recover, maybe restart the whole thing to factory reset. Okay, I know most of you have experienced that before. And you don't need to get an operating system. You don't need to go and do formatting or go and get a pen drive or OSCD. You just sometimes open the window, type maybe reset, then the reset option will come. You follow the steps, and it will just reset everything for you to the scratch. How many of you have done that before on your operating system on your machine, which you use to reset the whole thing? How many of you?
Yeah.
Okay, all right. So all those things are there. Then we have the security and protection. So this is where the antiviruses and the firewalls also come in. Okay. So they are there. Then we have other encryption tools that are also there. Then others. So these are the self-explanatory, which you can. Then we have some diagnostics tools too you can also use. Or in case you think some of your OS is corrupted, you can use some diagnostic tool to you run it and it goes through, then it fixes the errors. Sometimes if there is light out, in case you are using a desktop or your laptop is plug and play, and you are using it, there's light out and it goes off, and sometimes later you on it, you notice that sometimes it will take you to a page where you have to, to take the diagnosis, sometimes you have to recover broken files or restore broken files, where you have to allow it to go through that process in order to have everything back as it's supposed to be. So all those things are part of the utilities tools. Okay. Okay. So any question? I think we are moving to the next section. So in the previous section, we've explained the different categories of softwares and we've looked at how important they are. Now let's move into what? Programming languages. Okay. Let's move to programming languages. And we are just going to look at the surface. Okay, we are just going to start. We are not going to go in depth. So programming involves writing a set of instructions that a computer can execute in order to perform specific tasks. These instructions are written using programming languages. So to do that, you need to understand a particular programming language, understand the syntax, how to write code, how to write it in a way that it can be run and the computer will really understand. So programming languages can be defined as a formal system of rules and syntax used to construct programs. It provides a way for humans to communicate in a structured and meaningful form in which the computer system will understand. Okay. So since computer ultimately understands binary, okay, zeros and ones, programming languages act as an intermediary between human reasoning and machine execution. So the computer will not understand your English. So there should be a program language that you write probably in the language you understand, and it's going to interpret or convert it to the language the computer system will understand. So over time, programming languages have evolved significantly. Early forms were closely tied to machine language, machine level instruction. So in the past, programmers were writing codes in zeros and ones because that's the languages, the binary language, that's what the computer system understand. So in case you want to write print something or play a sound, you have to write it there, and that's a lot of work. But people were doing it. So imagine those days, the work they were putting in order to build a particular software. Everything was written in zeros and ones. Okay. Everything was written in zeros and ones. So after that, then but in currently modern, we now have languages in plain English, user friendly. And that's how programming language has evolved in the past years. Okay. So now you can write codes in English, plain English, and it will be converted to the machine language the machine will understand behind the scene. And when you are getting response, the same, you have an intermediary that will convert it back to raw English for you to understand. Okay. So in this section, we are going to look at programming languages. That's like the machine language. They will look at the assembly language. They will look at high level and fourth generation language. Okay. So each of these languages has its own complexity and the way instructions are executed. As I said, we'll not go much into details. We'll just go look at the surface. Now, machine language, when we say machine language, so machine language is the lowest level of programming language. Okay, it's the lowest form of programming languages and is directly understood by the computer processor. It consists of binary digits represented by combination of zeros and ones. So as I said in the past, programmers were writing in zeros and ones. They will write it, code it for the hardware, the processor to understand. Okay. Now, so we have the machine languages. So over here we have pure binary zeros and ones executed directly by the CPU, high performance. So it has its characteristics. So let's look at the machine language, characteristics of machine language. I think I don't have it in the slide, so I'll try and put it there before uploading it. So the machine language characteristics, it has, even though we have it here, okay, we have it here. So it uses binary code, which we understand, zeros and ones, okay? Then it's executed directly by the CPU. So there is no intermediary, straight with the CPU. It is hardware dependent. So because it's zeros and ones, it is hardware dependent. It has to, it's not a program language that you can move from one. So if you are dealing with the hardware and you are programming for, let's say, a laptop, that same language or assembly machine language will not work for a mobile phone board. It will not work for a washing machine. Okay, so it is hardware dependent. So when you are dealing with the hardware, you code it to fit that particular hardware. And that's very, very difficult. You have to, so every device or every component you have to understand how the hardware is structured and make sure you program to suit it. Okay. And it provides maximum control over system resources. Because you are dealing with the hardware itself, it gives you the chance to control the system itself. That's why when you are dealing with the BIOS, you can control, if you log into your Windows BIOS, where you are at the latter part. Because the BIOS is there before the operating system. That one you are dealing with what the hardware. It's just the BIOS it has been, because of modernization, it's now have graphical interfaces. But in the past, it's not graphical interface. It's just sometimes there are commands you have to instruct. So you can go to the hardware in case you have a laptop or let's use the desktop computer. You can go to the BIOS and disable the CD-ROM, disable the USB-ROM, USB drive. You can disable the network. And as soon as you install the OS and you boot, you realize all those functions are not working again. Because it gives you that control. And if you are coding assembly language, you have control of the board, the component itself. You have full control of it, and you can just maximize its control. You can restrict what you want to be available or want not to be available. Okay. So that's the characteristics, and it has advantages. So with the advantages of machine languages is that it executes quickly because it does not require translation. Okay, there is no intermediary. You are dealing with the board itself. So anything you do, it goes faster. There is no intermediary. Then two, it allows precise control over hardware operations. So those are the advantages. Then it also have a limitation. Okay, so the limitation is that it's extremely difficult for humans to read and write. You are writing everything in zeros and ones. If you want to write A, you have to write just A in zeros and ones, B in zeros and ones. So if you are doing C in and C out, see the stress you are going to go through. Okay, it's not for everyone. Okay, then it is prone to errors due to complexity. You can do minor errors. You will not even see the error because you are writing everything in 0 and 1. So something that you have to write 0 because it's in like 0, 1, 0, 1, 0, 1, 0, 1 in a line. You can mistakenly neglect 1, 0 or convert 1, 0 to 1 and automatically the language has changed. Debugging it will be extremely difficult. I hope you are following.
Yes, sir.
Yes. Then it is not portable. That's the limitation. As I spoke earlier, you can't, the same language, you can't move it from a computer system and go and put in the same language, assembly language in a mobile phone. They are two different boards. It will not work. So it's not portable. So those are some of the limitations. Okay. There are more. I'm sure when I release the final slide, it will be there, or it will be in the book that I'll be publishing on the platform. Okay. Now, from the machine language, the next language that came, which was a little better, was the assembly language. So they realized the machine language was too tedious. So they decided to go towards advanced, where they decided to build a machine assembly language, which is more human friendly compared to what? The machine language. So assembly language was developed to simplify programming at the machine level. Okay. Instead of using binary code, it uses symbolic instructions known as mnemonics. Okay. I hope you know mnemonics.
No, sir.
Do you know mnemonics?
No, sir.
No.
Wow. Can anybody Google mnemonics and just the word mnemonics? Mnemonics, MNENONICS. Then the person should explain, should read it out for us so that we understand what mnemonics means. MNEMONICS. Do you have anyone? Okay, Johnson. Meaning of mnemonics.
Mnemonics are memory-enhancing techniques such as acronyms, rhymes, or mental associations designed to improve the encoding and recall of information.
Okay, so that are mnemonics. So they are just acronyms. Like the way instead of say central processing, you say CPU, and it has come to stay. Do you understand? So they were using mnemonics. So instead of doing addition, you do add, and the system will understand it as addition. Subtraction, SUB, the system understand it as what subtraction. Division, DIV, then the system. So you program it using languages that you know. You've created mnemonics, and it represents something that you should have run and you should have written a lot of zeros to do, zeros and ones to do. I hope you understand. So that one became something that was closer to human, and it was also used in dealing with what the hardwares. But this time, you don't write zeros and ones. You have mnemonics that you use instead of the binary hardware. Then it works perfectly for you. Okay. So, for example, let's say you are doing an addition of maybe variable A and variable B. You simply just use the word add, ADD, and the system knows that you are adding this to this, and you are good to go. Okay. So that one also have its characteristics. Sorry. So that one also have its characteristics. So the characteristic is that it uses symbolic codes instead of what binary, which I've said out as the mnemonics. Then it requires a translation called assembler. So with the assembly language, the machine language doesn't need any translation. You are dealing with what? The machine directly. But for the assembly language, it needs a translator because you are writing in mnemonics. You're writing the code in mnemonics. The machine language, the hardware doesn't understand the mnemonics. There should be a translator who is going to translate it into zeros and ones. And we call it what? The assembler. Are you following? So when you do those things, then the assembler will convert it to zeros and ones for the machine to what? Understand. Okay. And it also provides low access. It provides low access to what? The hardware. So the machine language provide more access to the hardware, but the assembly language provide low, because that one there is an assembler and certain things will be restricted because it is being converted and you are not dealing with the hardware directly like the machine language. Okay. But you still have access to certain hardware, but not everything. Okay. It is also what? Hardware dependent. So it's just like what? The machine language, which is also hardware dependent. What you write here, when you go to another place, you have to start from the whole scratch. Okay. So advantages of it is that it's easier to understand than machine language. It provides greater control over system resources. Okay. And also it's more efficient than higher language in certain applications. Not all. We'll look at higher languages. So in certain applications, it is more efficient than higher languages. So the limitation too is still complex compared to today's modern languages. Because even though you are using mnemonics, but it's still complex. It's not like the English we talk or we speak fluently. Okay. And it also requires knowledge in hardware architecture. You have to understand that before you can use this particular assembly language. And the programs too are not easily portable, which I also understand. Okay. So that is some of the limitations of the assembly language. Okay. Now let's move to what we have today, higher level language. And most of the language that we use today are higher level. The program, all of us are. Those who are still using the assembly language are those who are in the physics lab, trying to create things like you are programming the board and other stuff. They are still using the because if you are into correct engineering and you are programming board and chips, you will not be using the C++ and the rest. You'll be using the assembler languages, the C. We have C and we have C++. C itself is an assembler. It's not a higher level language. It's intermediary. You can use it for higher level, but usually C is used to program boards. I hope you've heard of C.
Yes, sir.
Yes. So it's intermediary. You can use it for as higher level, but usually it is used to program boards itself. So that's one of the most one that is similar to human a little, but it's usually used for programming what boards and stuff. All right. So let's look for higher level language. So higher level languages were developed to make programming more accessible and efficient. This language uses syntax that is closer to human language, making them easier to learn and use. So example of higher level language, we have what Python, we have Java, we have C++, we have JavaScript, we have HTML, we have, there's a lot. We have C#, we have Visual Basic, .NET, we have VB6, we have QBasic, all of them, the basic, they use normal languages to do it. But currently, the ones that you have, the Python, the Java, and the C++, they are little, even though it's human like, right, they are a little difficult. But the Python and other stuff, the ones that are coming out there, they are very, very, very easy to learn. Okay. Now let's come to the characteristics of the high level languages. So it has what? A human readable syntax. Okay. You have a readable syntax. So you are doing programming, right? Are you writing codes?
Yes, sir.
So which program language are you doing? Are you using? Is it C++? Is it Java? Or you
Pseudocode.
We are only writing
pseudocode? Is that?
at the
Pseudocode.
moment, writing only code.
We started with pseudocode.
Oh, okay. But I hope it's going well.
Yes, sir.
Okay,
Gradually.
sir.
Okay. If it's not going well, you should let us know. Because I'm sure during the exam time, you'll be writing codes on paper. So you should just tune your mind. It will not be something you'll be using your machine to debug and stuff. This one, you'll be writing it on paper. So you should just make sure you just grab it very well. Okay. All right. So characteristic of higher level languages. So what I said, it uses what human readable syntax. Then they are machine independent. So you can write Python code, and the same code you can compile it and execute it at mobile. It will work. Okay. Java, you can write Java for phone, and you can still write the same Java code, just change it and compile it, and you can run it on what? Computer. It will work. Okay. So that's the advantage of most of the higher level languages. Okay. Then it also requires translation. It also requires translators to translate it into what? Machine language. So the assembly language needs a assembler. Okay. But the high level, they also have what they use. We have the interpreter and compiler. We'll look at those one later. Okay. Then when it comes to the advantages, it's easier to learn and use. It reduces development time. That one you're writing normal English, so it's easy for you to write the codes fast, and it improves program reliability and maintainability. So because it's English, like when you're able to do the documentation and you are not there, anybody who takes the documentation can what? Go through and either continue or modify or upgrade what you have. Okay. So you read through, then you understand. Even though you are not the one who wrote the code, You can just go through and understand where the direction the code is going, the program is going. Okay. Then the limitation is that it also requires translations, which may reduce executionable speed. So because there is a middleman there, when you are running it, it may reduce the speed. It's not the speed as it's going to reduce it, but it won't be faster like the other ones. But sometimes if you have like 1 billion lines of code there, then the speed will down there you see the reduction. Down there you see it in real time. But if it's just like 20 or 100 lines of code, that one there you don't even see it because it's microsecond. Okay. And also provide less control over hardware. You don't have the control over the hardware like that. Less control. You can just use it to block certain things. Maybe you write a program that is going to you are supposed to activate your location before you can use it. So that one, so you can have access to certain things. Maybe your camera needs to be on, or your microphone needs to be on, and all those kind of stuff. But to get access to certain hardware, you can't use it unless you go into using the assembler languages, which can give you access to what the hardware component itself. Okay. So high level language is widely used as at now, as I said, and we have what examples are a lot. They are used in software development, website development, data analysis, artificial intelligence, mobile language, and the rest, mobile programming, the rest. So all of them use what high level languages because the language is human-like and we can understand. Write it in English and we are good to go. The Chinese people are writing this in Chinese. Ghana, we are writing it in English. By this time, we should be writing codes in Quaye and Ghana and Ewe and Hausa. We'll get there one day. Some of you are supposed to become experts and do projects on those things. Or it's not possible.
It's possible.
If the Chinese people are writing in Chinese and stuff, we the other time we are writing in English. Oh, assemble. All right. So now let's move to the fourth generation language. So we have the 4GL. Okay. The fourth generation languages are often referred to as the 4GLs and are designed to further simplify programming by allowing users to specify what they want to achieve rather than how to achieve it. Okay, so that's the difference. So users as well. So these languages are more abstract and are often used for database management, report generation, and data analysis. Do you understand? So for data analysis, you program like this is what you want. You want a bar chart or a graph. Okay. And the system will look at what you want and is going to generate it for you. Okay, so I hope you understand. So that's the difference of that. And it's only used in specialized code, as I said, for certain purposes. So when we come to the characteristic of the fourth generation, it focuses on problem solving rather than detailed programming steps. Okay. Then it uses simplified syntax and command. So if it's a database, you are querying something, you just write query, simple tags, and it will just do it for you. Simple. You don't need plenty stress, plenty lines of code. Okay. Then it often includes graphical interfaces or query-based instruction. Require minimal programming knowledge. Okay. So you don't need to be that good in programming to use this softwares. So advantages, it increases productivity, reduces development time, make reprogramming accessible to non-specialists, and it also has limitations that's less flexible for computer system development and may not provide fine control over system operations. So the books will have them, which you can look at it. Okay, so we have it here. Then we have example. You can look at SQL query language, which I made earlier, or report generation tools, okay, or some scripting or automation tools. So the SQL is the one that is close to us. We maybe if you come to my end that maybe your results, you have a results issue, blah blah blah, I'll just go into the system. I take your index number and I can query you and get all your information. Okay, I'm just interested in the final result, so it's going to do all the other works for me. I don't need to do serious coding in order to get what I want, and that's example of the 4 gene languages we are talking about. Okay, so we can have when you go to the slide, I think the book we are going to have comparison of program languages and the rest. So that one will leave it. Now let's move to compilers and interpreters. Okay. So in the previous session, we've looked at, so now we are going to focus on the high level languages because they uses the compilers and the interpreters. Okay. So in the previous session, we examined the different categories of programming languages from machine language to high level language. Okay. So why these languages make it easier for humans to write programs, most of them are not directly understood by the computer. Okay. So as a result, there must be a way to convert the human-like readable instructions into machine-level instructions that the computer can execute. This process is known as translation. Okay. So in order to convert from high-level language, like human-like language, to machine language for the computer to understand and execute, we call that particular process translation. Are we here? So the translation is carried out by a specialized program called language translators. There are two main or two most important types of translations, which we have with the compiler and interpreters. So the high-level languages that we have, they have these two things. Some have the compiler, some uses the interpreters, some uses both. When you come to Java, Java uses both. It's compiled partially and it uses the interpreters partially for Java. But majority of them will use either the compiler or the interpreters. So we'll look at it for you to understand it well. So these tools play a key role in software development by converting source code into a form the computer can run. So you write it in English language, and these are going to compile it into a language and the computer can understand and run. Okay. So when we come to the concept of language translation, okay, so let me still be here. Okay. It has a concept in which the computer language is common. So programming languages such as Python, Java, and C are written in the form that, or C++, are written in the form that is understandable by human. However, the computer processor can only execute instructions in machine language, which consists of binary codes. To bridge this gap, you need to convert all high-level languages into machine-level languages for the computer to understand. So the concept, how the computer does it, how the program does it, in order to do that, first, it analyzes the code. Okay, so the code you write is going to analyze it, check errors. After checking errors, translate the instructions into machine code for the machine to understand. Then prepare the program for execution. Compilers and interpreters perform these functions in different ways. So both of them do that, but they have their own ways in which they do it. Even though all of them are doing the same job, but they have their way of in which they execute. So we look at compiler first. So compiler. So a compiler is a program that translates an entire source code. So there are certain keywords you need to understand. A compiler is a program, and it's not a separate program. It's in the program you've installed. So don't say like you have to install a compiler different before you install the program language software different. No, it's in the programming language. So if you are coding in Java or C, the compiler is already in it. Okay, and that's its job. to translate it after you've written it in English language to the language the computer will understand. So a compiler is a program that translates the entire course code written in higher level language into a machine code before execution. So what is that? When you write the code, it converts it, the whole code. So if you've written 100 lines of code or 1,000 lines of code, it's just going to compile all the 1,000 lines at once. Okay, so it compiles before it what executing it. Okay, how does the compiler works? So over here we have what bulk. So as I said, it compiled the whole program into machine code. Okay, and when it does that, it creates what executable file, a file you can click and run. Sometimes it's not complete. So when you run something, you get error, though, but it completes, it creates a file. If you are someone who have coded in Visual Basic before, you notice that as you are running the program or you are testing the program, it's creating the executable file somewhere. So if you think finally you are done, you can just even close the software, go to that place, run that particular executable file, and this program runs. So you can even copy it to someone. If you want to copy that software to someone, you can just copy it to that for that person, and the person can run it. So that's what the compiler does. Okay, unless maybe the executable file also need certain information that you have on your machine. Maybe some files that is linked to it. That one to not run. But if it's just a standalone, automatically you copy it and it will run. The person can run it everywhere he finds himself on a different computer. Okay. So that's what the compiler. So how does it work? So in compilation, the compilation process typically involves several stages. So first we have what we call the first step that we call the lexical analysis. When the compiler is compiling the whole code, it goes through what we call the lexical analysis. It will be in the book, or I think it will be in the final slide. When I put it there. So don't worry, okay. If you are student, don't worry, you see it later. Okay. So the compiler, so when we say lexical analysis, what the compiler does is the compiler reads the the source code and break it into smaller units called tokens. So you've written like 100 lines of code or 1,000 lines of code. It's just going to read the source code at once and break them into tokens, smaller units. Then it goes to the next stage, what we call the syntax analysis. So when we come to the syntax analysis, what it does is the compiler check whether the program follows the correct grammatical structure of the programming language. So every programming language has its grammatical structure. How the grammatical structure for C works is not the same. It will work for C++. They may be similar, but it's not the same thing. For Java, it's not the same thing. For Python, it's not the same thing. They are different languages. That's why I call it programming languages. It's just if you understand how to write codes in maybe Java, it's easier for you to learn other programming languages because they follow the same syntaxes and strategy. The in and the input, the output, the if statement, the looping statement, they all have the same thing. The functions, but probably the functions will be written in another way, in another style. Some programming languages will end with comma. After I write the code, you should end with comma before going to the next line. Some will prefer semicolon. Some don't want anything. I hope you understand. So you have to understand. It checks whether you are following the grammatical structure of the programming language. And that's what we call the syntax analysis. So you check the syntax. If there's an error, it tells you syntax error. Do you understand? If it gives you syntax error, then you have to know where the issue is coming from and where to look for it. Okay. Then from there, it goes through another one called semantic analysis. The semantic analysis, the compiler verifies that the program statements make logic and sense. Do you understand? So if there are, it checks the logical of the flow have to make sense. If it doesn't make sense, it will give you an error. And when you guys start doing the real program, you'll be experiencing some of these things. So sometimes you write a semantic analysis, a code, then the computer will compile, this guy wants me to overthink and jam my system. So it will it will give you that error. The step will not even run, it will break on the way. Okay. Then we have the code generation. So after it has gone through all this, then the compiler converts the course code into the machine code for intermediate code. So into the machine code or intermediate code. So that's when what the code generation comes in. So it compiles everything. Then finally the compiler improves the efficiency of the generated codes. Once it has gone through all this process, then it executes and it runs directly, then the output is displayed to you. So these are the 5 steps a compiler goes through. So we have what? The lexical analysis, we have the syntax analysis, we have the semantic analysis, then we have the code generation, then we have what? The optimization. So these are what? The 5 steps in which a compiler goes through and order. So when you write and you run the code and you get the output, you are happy, you get it in a fast way. Within a second, you have the output. But behind the scene, all this thing has been done before you get to what? The output. Okay. Now, characteristic of a compiler. So the compiler translates the entire program at once, which I've said earlier. So compiler translates the entire program at once. It doesn't do it line by line. It makes sure it compiles everything and translates it at line. It also produces an executable file, which I've also explained earlier. Okay, it will produce a file which you can .exe, which you can run. Okay, then it detects error during compilation. So during the compilation, it detects error. It doesn't detect error after compilation, during the compilation. So you have to know the characteristics, because interpreters does, even though they have similarities, interpreters does it differently. Okay, so during the compilation, it detects what? The error. It's not after compilation. Then it requires recompilation after changes. So when it detects error and it stops, and you correct the error, you have to recompile again. So when you are using a graphical interface, let's say I want to use Visual Basic, VB.NET. After I write the code, I should have installed it and even displayed it to you. Whilst this and by my dream, I could have done that. I don't have it on my machine. I would have written small code and run it for you to see how the compilation works like. So for VB, you see a run. There'll be a run button you can click, or C#. When you click on it, you see it's compiling. You see the word compiling, then it compiles it. If there's an error, it stops. During it stops. Then it will give you the error, the line. You see the line in which the error is. You go into the syntax, study the line very well. Then if you have to do correction, you correct. Then you compile again. If it says another error during the compilation, it will draw attention. The compilation will complete if there is no error. Do you get it? So the program will not run, even if it's 2,000 lines of code. If there is an error at number 1009, the whole program will not run. But for interpreters, the program can run up to 1009, then stop there. They let you know that, oh, you have issue at, it has run already, but it will just pause at 1009 for you to know that, okay, this is the issue where you have to start from and continue and correct the issue. But for compilers, it will not do that. If you are not able to detect the error, then your program will not run at all. Okay, so that's the difference. Okay. Then we have what? Advantages of compilers. So compilers have its advantages. So programs execute faster after compilation. So when you compile, it runs faster because you've already compiled it. All errors have been corrected. Then you run back, you are good to go. You run back, you are good to go. You run back, you are. So when you are building on the code, it's easier. It's easier because it has compiled. Let's say you are writing a code that is, let's say, 1 million. You've done 500,000 of the code. You've compiled. It's working. You continue. As you continue, you did another 200. It was giving you an error. Now, the system, because you've compiled, anytime you decide to run again, because the first 500 has been compiled and there's no error, it doesn't compile, it's already compiled it into memory. It doesn't compile the first 500. It will only work on the other ones, work on it, then it just. But when you are dealing with translators, translators will always start from code 1. Anytime you decide to run, it's going to start from code 1. It doesn't matter that 100 to 500 is 500,000 code are already working. No. It will always start from the top down. Okay, so that's one of the differences. So that's the one advantage of compiler. It's actually faster after compilation. Errors are identified during execution. As I said, so during, when you are trying to compile it, then errors are identified. Okay. Then it's what? It's suitable for large and complex application. Do you understand? So if you are building large applications, then it becomes better where you can, know you do chunk by chunk, because you've done first portion, it's working well. You know it's working well. You come to the next portion, chunk by chunk, and it's coming. So if it's a big software, it really helps you in terms of debugging and the rest. There is task limitation. Sorry. So the limitation, compilation may take time, especially for large programs. So it will take time. That is, if the program is big and you are now compiling from the scratch, it has to run, there's error, you have to wait, and the rest. So errors, and then also error must be corrected before execution can be proceed. Okay, so that's also another limitation. Then it requires more memory for storing compiled code. So you have to have more memory space because of how it works. It has to compile, keep it in memory. So examples of it is what? The C++, C#, and the rest, VB, Visual Basic.NET. Then we have Java, but Java is partly. So Java has a console. That's one. So Java has a console and has the graphical interface. So Java is partly compiled into what? Bytecode. So Java is hybrid. Java is like a hybrid. It has both. It has some with compilers. That's not what interpreters. Yeah. So just Java is only different. So in case there is an exam and they are giving, you should give example of compile and you see Java there. And the other examples are not, you can put Java there. But if the question says which of them is hybrid, then you know that is Java, because Java has both. So it falls in what? Both of them. Okay. So just keep that in mind. Now let's come to interpreters. So an interpreter is a program that translates and executes source code line by line, rather than translating the entire program at once. So it does it line by line. And anytime you run it again, it's going to start again from the top, line by line. Okay. So how does the interpreters work? So for an interpreter system, how it works is that first, interpreter reads one line of the course code. It reads. After reading, it translates the line into machine language or machine instruction. Then immediately executes that instruction. Then move to the next line. So you are seeing the difference. The compiler will not do that. Do everything at a go before executing. But for interpreters, it reads one code, one line. Now it executes, convert it to machine language or the language the system execute. Then move to the next code, execute. Move to the next line, execute. Move to the next line, execute. So when it does that, it gets to a line that there's an error, then it pauses. So if you are running it in console, you will notice that you see the output in case you have given a command for it to display names, maybe 100 names. And maybe at age number 90, you decided to make a mistake and you run it. You notice that it will display all the names to 89, then it will pause. They tell you that there's an error here. But then it has displayed all the top, it has run the top already. But compiler won't do that. Compiler will make sure everything is correct before running. I hope you are seeing you are getting to know the difference.
Yes,
Yes,
sir.
sir.
Okay. So this process continues until the entire program has been executed. Then characteristic, when it comes to characteristic of, and with that one too, it doesn't create no executable file. Okay. Then when it comes to characteristics of it, interpreters translate and execute code line by line. They do not produce separate executable file. Detect errors during execution. Okay. Detects error during execution. Then allows immediate testing and debugging. So those one, they can allow you to do debugging tests. So you can run the program as a debugger. So even though there's error, it will still run. It will let you run. It will run from starting to end and let you know that, oh, there's error here, there's error, there's error. So advantages of interpret. So it has all advantages and disadvantages. So you have to know which one you may use as you start to understand the program languages you are comfortable with. You have to understand how they work so that when you are working with it, you know which one best suits you and your programming style. Okay. So when it comes to advantages of interpreters, let me see the time. Hey, it's almost time. Wow. So when it comes to advantages of interpreters, today I've been moving slow. Um, it simplifies debugging by identifying errors line by line. It do not require separate compilation and allow quick testing. It also have limitations, which I think we'll look at it in. It will be on the PowerPoint after I put the final one. Then you have the hybrid approach, which I told the hybrid approach is basically for the Java one. So Java uses both, and modern programming language often uses the combination of interpreters and what compilers. And I said Java is one of them, which uses what both. So let me see. How many of you have knowledge in website development? Do any of you know how to design websites or know how to use HTML? Do you have anyone?
Yes.
Okay. So you that you know HTML. So do you think when you write code and you run in HTML, does it use interpreter or a compiler? From how it has been explained, what do you think it is? Is it an interpreter or a compiler? Hey, Madam who said yes. Madam is not talking again. No. Okay, so when it comes to the HTML, it uses interpreters because it runs line by line. Okay, line by line. So when you write your syntax, like let's say you've done your head, you've created your head, your title, your body, and you give the body color. You start giving paragraph by paragraph. It runs from the top down, and it runs line by line. Anytime you decide to run it, it's run by line. So what I advise the classes, everybody should try and learn how to build websites. Okay. Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Everybody should try and learn how to build websites, and it's very interesting to learn. And you can all that you need is a notepad, and don't go in for the easy way. Someone will tell you, oh, you can use WordPress, you can use Joomla, you can use Drupal, you can use Shopify, and those kind of things. And that's the easy way. That one is for the non-IT guys. As an IT person, you have to start with a notepad. I believe you only need notepad to design a website. Do you know the notepad you have on your computer? That notepad. Do you know?
Sir, I've been seeing something like that. Sometimes I want
Yes.
to write something.
So to design a website, all that you need is a notepad. The notepad that is on your machine. You can use it to design a complete website because HTML will be on notepad, CSS, everything can be on the notepad. And you can design a complete website with just writing codes on a notepad. Okay, so just all of us try to learn. I think our time is up. Let me see if I can. I want to see what is left if it's easier for you to read. So we've done the hybrid approach already. Let me see. I think what is left is easier for the class to read. So we have the source code. So let me come to this side and see if I can just finalize this one for you guys. Okay, so source code and object code. So let me explain just source code and object code, and I think later I can read the book to understand. Okay, so in the previous session, we have explained how compilers and interpreters work and how they translate program written in higher level language towards machine level attributes. But to fully understand how translation process is done, it is important to examine two fundamental concepts, which we call the source code and the object code. Okay. Now, the concept describes different stages in the life cycle of a program. Source code represents the original instructions written by the programmer. So the code you write is the source code. Okay. So if it's pseudo code or any code, it's still the source code. Okay. While the object code represents the translated version of those instructions that can be executed by the computer. So when you write the source code and you run it and it goes through whether the interpreters or the compiler, it converts it to something the system will understand. That is called the object code. Are you following? So the source code is what you write in English, and the object code is what the computer understands. Understanding the decision between source code and object code is essential for IT guys. So when it comes to source code is the original set of instructions written by a programmer using programming languages. It is written in human readable form and follows the syntax and rules of the chosen programming languages you are using. So if it's Java, you have to follow the rules and the syntax. If it's HTML, you follow the rules and the syntax. Okay. Now, the characteristics are there. I'll not talk about the characteristics, which I think if you read, you understand. Then when we come to object code, the object code in definition is the output produced after source code has been translated by a compiler or an assembler or a translator. Do you understand? So as soon as it converts it becomes what? An object code. It is written in machine language in a form very close to it. So either it's in 0 and 1s or very close to it for the computer to understand. So that's the difference between the source code. So we have the source code, original human readable instruction written by the programmer. Then it transforms. So we have the transformation where it transforms what? The object code. So after everything has been done here, then it comes the object code. And backward from the object code, for it to come back, it comes from the object code to what? The transforming back towards the readable one for the programmer to what? Understand. I hope you are okay. You are following it.
Yes, sir.
Yes, sir.
So that's it for object code. I think when you read the book, I'll put the book there, so I think you understand it very, very well. In case you go through the book and probably there is something you didn't understand, I think the next time when we meet, you can just bring it up. You can bring it up, then I'll do my best to explain. I believe you understand it very, very well. So I think the hybrid, I was talking about the hybrid, and we have selection criteria for selecting a programming language. I think that one needs to be in the book, and when you read, you understand. So I think I'll end the section here, and I'll see if anybody have any question for me. It's 2 minutes to time so that you can. But just keep in mind, if in case you join late, we'll be having our midterm on Friday. Okay, we're having our midterm on Friday for 20 marks. So I will be uploading the questions on the LMS. It's going to be objectives and some feeling. I'm thinking of doing some small short answer or sentences. I may put some short answer there, which you have to type and submit, which I will mark manually. It's 20 marks. So Just make sure everything we've learned from day one till now, you just go through the book. And this is going to be similar to how the exams is going to be like. So the midterm will let you know how some of the questions that are likely to come in your final exams. Okay. So we'll do that on Friday. I'm going to open the portal from 6 a.m. on Friday, since Friday is a holiday. And the portal will close 11:59 p.m. So which means you have 18 hours. So the 18 hours, you can choose to start anytime as soon as you start. I don't know whether it's going to be a 1 hour paper or 30 minutes, or I haven't decided yet. So you start, you have the time, you do it and you submit. Then you will not see your mark until the portal closes. That is if I decide to do it only objectives for the system to mark. But in case I put in a written, which I have to mark manually, then I have to mark first all the manual one, because the system will not be able to mark the essay part, because the essay part have to be read by a human, so that I can know whether I should give you 2 marks or 1 mark or 4 marks or 5 marks. Okay. Then I'll finish. As soon as I'm done with the marking, I'll let the course rep. Then you can go to the platform, see your grade. Also, next 2 weeks we'll be doing face-to-face, and the group work I've given you, you guys should try your possible best to put things together. And you come and teach the whole class, including me, about the topics I've given you guys. So we'll be doing that the last week. So in case your group haven't met or you've not started anything at all, you only have 2 weeks to do a presentation in the class. And the presentation, I'll be marking performance, contribution, and students who will be asking questions to will be getting marks. So if your colleague come and present and you don't want to ask questions, then bear in mind you are losing marks, because 10 marks. 10 marks. So I'm going to distribute. I'll show you how I'm going to distribute the 10 marks, what the presentation will take. Audience asking questions too, but not any question. It shouldn't be any question because you are supposed to ask. It should be sensible question. Any audience who asks a sensible question or a very good question will get an individual mark for answering that question. So everybody have to be on standby for that. Okay. So I think we'll end our session if there's no further question. Is there any question? Okay, Johnson. Johnson, go ahead with your question.
Yes, sir. Okay, so please, this is not a question, but so the on the LMS, please, do you complete every slide before you get 100%?
The LMS, you need to at least download. You need to download all the slides. You need to download the slide, but I think I've disabled some of them. If you check today, I've disabled some of them. It's just certain things I need you to watch, especially the introduction videos. I want you to watch the introduction videos and the rest. So just keep that in mind.
I've seen that I've completed every single topic there, but I'm still not at 100%.
Oh, really?
Yes. I completed everything this week, and this done, I completed what you have.
Okay. There is an activity. Okay, let me show you. I think this is the reason why you're not at 100%. You are at 90 something, right?
No, I'm at 57.
Oh, really?
Yes.
Oh.
And I've read every single thing. I've answered a couple of questions.
No worry. I'll look at it later. It's not an issue. You shouldn't worry.
Okay.
It's not an issue. Okay.
Okay, sir.
I'll look at it.
Isn't it going to affect my grades?
Oh, no. It will not affect your grade.
Okay.
It's not. Sure. No worry. All right. So I think if there's no further question, I'll leave you. We'll be meeting tomorrow, right? For digital. Have you done the assignment?
Yes, sir.
Okay, so tomorrow you'll be marking your colleague's work then. So everybody should make sure you have your laptop with you, because as soon as I flip over, you are going to see your friend's work and you are going to mark their work. Then we continue. I think tomorrow when we are done, we can start with the prompt engineering. And then we do it fast. Partial. Okay. All right. So I will meet tomorrow, and I wish you all the best.
Hello, sir.
Hello, boss.
So please, those of us who are not having the distance, that's the laptop. How are we going to mark our colleagues' work? And moreover, how are we going to do the the medicine.
Say we will get laptop for everybody.
The medicine, you can do it on your phone. You can log into the LMS, right?
Okay, yes, please.
Yes, you can use your phone to do it. But for the flip exercise we'll be doing tomorrow, you can still use your phone if I flip, but it's just sometimes it will be, the interface will be a little difficult to maneuver. But if you can find your way on your phone interface, you can also mark. Those who are not able to mark, don't worry. Maybe after the session, I'll go through and even the final mark, I'll be the one to give the final mark. So I just want you all to have a feel of how to do peer review. Do you understand? And that the LMS can support that. So when we do that, those who are able to mark, fine. If you are those who are not able to mark, depending on whether they don't have a laptop, I will do the marking behind the scene for them. Or I can reassign it to someone else. Okay, so it's not an issue. Okay, all right. So any other question? Jonathan.
So which work are you talking about tomorrow? Is it a Padlet?
Yeah, the Padlet work I gave.
Okay.
Now you have to create your own, put in some information, then submit the link. Then
Okay.
your other colleagues are going to review your page and mark what you've done, whether it's nice or the information you have there. Then they'll give marks. Depending on the criteria I'm going to give, they'll follow the criteria to give the marks.
Okay, sir.
All right. So I think if there's no further question, today is not St. Close page, so I think we have to end our section and we continue tomorrow. Will you be using the same link for the next class? So that I just leave you. Okay, so I'm leaving the class for the next lecture to join. So we'll meet again tomorrow at 11 a.m., right?
Yes, sir, 11.
Okay, so all the best and bye-bye for now.
Okay.